When one considers the defining characteristics of scientific inquiry, the role of theory-making or hypothesizing can clearly be seen to take a central place in the process. It is within the scientific hypothesis, the description of a system that is able to make testable predictions about its behavior, that the lion's share of the scientific knowledge lies. Resting on a foundation of empirical data, created through observation and experimentation, it is the hypothesis that encompasses all that a scientist knows or suspects about a system, and it is what, in the cases where the hypothesis takes on the characteristics of a proper scientific theory, provides the best explanation of the system being studied. But when one considers the nature of the knowledge contained within a hypothesis, there are a number of questions that can arise. Can the hypothesis be said to be a description of reality, or merely a means of explaining the data that has been collected? Should scientists and others view the various laws and theories that have been accumulated as the best attempt to understand some objective reality, or would that be putting too much faith in the value of the knowledge that they contain? While such ruminations may seem to be the esoteric playthings of philosophers and madmen, far from the concerns of the practicing researcher, engineer, or technologist, they are of significant relevance to the history of the subject we have been considering for the last 45 episodes of this podcast, and their implications resonate today from the laboratories of the University of Delft to the offices of the theorists in Princeton at the Institute of Advanced Study. And while there have been those who have scoffed at and continued to devalue the philosophical questions regarding the nature of scientific knowledge, when we talk about what the nature of reality is and how we know that, we are, all of us, engaging in the enterprises of metaphysics, ontology, and epistemology. Thus, it serves us well to know the history of not only the science, but of the philosophy of science related to these areas, so that we may better understand the implications of the questions we ask in our search for truth.
Hello, and welcome to the Scientific Odyssey. The Scientific Odyssey is a many-part journey into the history and philosophy of science. My name is Chad Davies, and I'm the writer, host, and producer of the podcast, where we consider the ideas, processes, and results of over 2,500 years of scientific inquiry and discovery.
Series 2, A History of the Atom. Episode 26, Philosophical Epilogue, Part Number 1, Positivism. Before we get started, a quick programming note. I had promised at the end of the last episode that this would be a show on the world's most interesting physicist. As I've gotten into my research for that topic, however, I've found that this person is a whole lot more interesting than I realized, and so I have a whole lot more reading and writing to do than can be reasonably done within a week, especially a week in which I'm giving exams. As such, I'm afraid that topic will have to wait a little while until I can get enough stuff under my belt to bring you something worthwhile that goes beyond what you might find on Wikipedia. In the meantime, I thought I would spend a couple of episodes talking about some of the things related to philosophy of science, a topic I am at least marginally more knowledgeable in, and that relates closely to some of the material brought up in the Bohr-Einstein debates. Hence, this episode and the next. When talking about the nature of scientific hypotheses, and by that I mean all types of descriptions of a physical system based on empirically obtained data, including models, organizing principles, laws, and theories, one of the big questions that comes up over and over is what those hypotheses are or what they represent. The sort of default position in this is known as realism. While realism as a specifically expressed philosophical position arises in the 19th century in response to something we'll talk about later known as logical positivism, one can see its basic assumptions going as far back in the history of science as one wants to look. What realism says is that a hypothesis, insofar as it claims to do so, is as accurate a description of the physical world as is possible with the data that's available. As an example, when Dalton said that the best way to explain the various chemical processes and observations of chemists like Lavoisier was to posit that there were these things called atoms, what he was really saying is that there really were super tiny spherical objects that were hard and indivisible that interacted in some way with other super tiny spherical objects to form all of the things we see in the universe. In other words, a realist says that the hypotheses put forward and used in scientific inquiry are an attempt to describe an objective, external reality with real physical things. While it may not be true that the realist position has always been the default option for those thinking about how to evaluate their knowledge of the natural world, I think that for most people living since the beginning of the Renaissance, or at least since the Enlightenment, this has been the case. It's certainly been true, I think, that outside of philosophical circles, the realist interpretation of hypothesis making has been the dominant position for most of the scientific community from the 20th century onward. And I think it can also be said that I think this is what most lay people think of when they consider science. When a study explains a set of data using something like atoms or genes or a force called gravity, the typical person usually accepts that there really are physical things such as atoms and genes, or something that pulls planets in such a way that they orbit around the sun. The modern mind, by and large, is realist in its assumptions about the nature of scientific knowledge. Realism, however, is not the only position. And at some times, and in some intellectual communities, it hasn't even been the most central or commonly adhered to way of looking at the task of creating descriptions of systems. What I'd like to do over the course of the next 2 episodes is look at some of the other frameworks to see how they have informed the process of scientific inquiry in the past and how they interact with it presently. In beginning our consideration of the alternatives to realism, it is useful to examine some of its assumptions. The first and most fundamental of these is that there is an objective physical reality external to the observer. That is to say, there is a physical world out there that exists and behaves independently of somebody who's looking at it. A second assumption is that this reality is accessible to the observer through the observer's senses in a consistent and understandable way. In more recent times, there have been those who have argued that one can include those means of observation that extend an observer's senses in some way, but there is some debate in how far this can be taken. For example, a telescope that gathers light to be directed into an observer's eye in order to magnify or enhance an observed object is generally accepted as a mere extension of the senses, while replacing the eye altogether with photographic film or a charge-coupled device is more suspect as to whether an observation using the senses can be said to have occurred. We'll return to this question in the next episode of the podcast. From these 2 assumptions, the philosopher can derive additional criteria about what a good scientific theory is, such as whether it makes claims that are either demonstrably true or false, and whether the theory is supported by evidence. As you might imagine, however, historically there are those who have challenged these 2 initial assumptions, and it is there where we will start. Broadly, those who reject realism, either in part or in whole, are known as anti-realists or non-realists. But these terms, I think, tend to define those who hold such views by what they are in opposition to, rather than on the basis of what they might claim about scientific theories and knowledge. As such, it is better to divide those who offer other perspectives according to what they claim to hold true. Due to the recent nature of this particular subject in philosophy of science, and by recent, I mean the last few hundred years here, it's a bit dangerous to go too far back in time to talk about the nature of scientific knowledge and the validity of scientific theory making, but there are a few things we can talk about. The earliest debates regarding these kinds of topics go back to the ancient Greek and Indian philosophers. Probably the first person who we have record of thinking that there might not be some sort of externally objective reality, was a man by the name of Anaxagoras, who taught that the reality we experience is something that is created by what he called, quote-unquote, mind, which held all things together, and it was this process that connected all of humanity, all those things that had an ability to partake in mind, to the cosmos or state of order. This type of view falls under the broad category known as monist idealism, that says that there is only one underlying truth from which all other things and all other realities originates. In most cases, this underlying truth or thing was not strictly physical and thus not directly observable by the senses. Most religiously based cosmologies have this kind of metaphysical picture, where there is some sort of supreme being or power that possesses pre-existing knowledge that is responsible for creating the physical universe, and that it is the character or nature of that being and its knowledge that determines the nature of the physical reality we experience. Therefore, it is not the physical universe that is worth knowing about, but rather the supreme being or principle. At best, observations or knowledge about the physical world are but a deeper gateway into the metaphysical and ontological truth. Another form of idealism found in the classical world is known as Transcendent Idealism, something perhaps best represented in Plato's theory of forms. As you will recall from our episode on the Athenian response to the atomism of Democritus, Plato claimed that the physical world we interact with is nothing but an imperfect shadow of a higher realm of perfect objects and ideals. Thus, for Plato and other rationalists of the times, it is better to understand the nature of the ideal realm of forms through the use of the mind than it is to study the natural world seeking to understand it on its own terms. The best one can hope for in understanding the physical world is to arrive at knowledge of the ideal through a study of the shadow world. A great deal of Neoplatonist thought through the Middle Ages will be of this sort of thing. Even the work of the scholastics of the 11th century and beyond, culminating in Aquinas' Summa Theologica, will be based on the idea that understanding the physical world is a pathway to better understanding the nature of God. And lest one think of idealism as applying only to positions related to rationalism or transcendentalism, it is useful to look at the work of George Berkeley. Berkeley believed that all things consisted of ideas and spirit, which some have taken to be fairly similar to the idea of mind, and thus he discounted the existence of what we think of as matter. In this, however, he does not reject the use of the senses to gather information, but rather embraces empiricism as a guiding principle of gaining knowledge by which ideas can be perceived. However, it should be said that Berkeley's data-gathering sense seemed to be more something like that spirit rather than the typical kinds of things we think of, such as sight and hearing. Another way of thinking in an anti-realist fashion is to suggest that one can't actually know what the real nature of the physical world is due to difficulties in perceiving it. Instead, the best one can do is to create an explanation of a descriptive or mathematical nature that allows for a prediction of the perceived behavior of the system. In this view, one can't know either the real nature of the actual system or, depending on the philosophical bent, the nature of the system's ideal antecedent. Later, this way of thinking about the scientific knowledge would become known as a phenomenalism position in anti-realism. An example of this we'll talk about in the not-too-distant future of the podcast were the attempts, beginning in the late classical Greek period through the Hellenistic world to the Greco-Roman period, to understand the nature of the motions of the planets in the heavens. Beginning with the work of the Babylonians and Egyptians, the Greek astronomers, beginning with Aristotle, working through Hipparchus and culminating in Ptolemy, attempted to build models that would explain the sometimes complicated motion of 7 specific objects through the sky. Most of these efforts were rather ingenious and fairly effective, but in general, their originators explained that they were not putting forward a model of what the heavens actually were, but rather a model that explained only the observations of the objects moving through the night sky on a daily, monthly, and yearly basis. While this was probably not the case for Aristotle's original cosmology of nested spheres, as the master of the Academy's empirical position led him to consistently propose descriptions from a realist position. Many of those who followed him, in adding first epicycles and then epicenters and finally equants, did so only in hopes of producing better predictions of where something like Mars would be in the sky on a given date, say for a festival of Jupiter or the celebration of the 10th anniversary of the reign of the Emperor Hadrian. Nevertheless, it seems fairly clear that in his magnum opus, a work known by its Arabic title, the Almagest, Ptolemy seems to suggest that his model describes an actual scale of the universe, a claim that takes his work well beyond being merely a mathematical calculation tool. For the phenomenalist, to hold something to be true, one merely need to believe that a given set of data obtained by one's senses is true, and that a particular description will produce that data. This position does not suggest that the description actually exists, or even corresponds in some way to what might exist. Rather, that only if it actually existed, it would be consistent with what has been perceived. Contrast that with the realism view that would say that if a model or description produces the data obtained by the use of the senses, then it is a description of the actual, external, objective reality. Another position, related to phenomenalism in that it is a theory related to issues of perception, is that of representationalism. This idea, found in the writings of Locke and Descartes, says that all we can access is our sensory data, just as phenomenalism does, but that the explanations we construct out of that data form only a representation of the objective physical world. The significant difference between the two positions is that representationalism says that some explanation is needed for the complicated and intricate order that we find in what we perceive. Additionally, the best explanation, that is, the one most likely to be true, is that those experiences are caused by and reflect the character of a world of objectively real material objects, which we have good reason for believing to exist. This is very much akin to the description of modeling given in the first series of the podcast, wherein we said that a model is not a true description of the real physical system, but rather an approximation of it that gets certain features of the real thing correct, but not all of them. Unlike the modeling process we described in that earlier episode, where we said that the model neglects features for simplicity's sake in order to get a better understanding of some basic set of underlying features or principles, representationalism says that our representation may well be incomplete because we're unable to get beyond the limitations imposed by our senses and the data they collect. In a sense, representationalism holds a place somewhere between phenomenalism and realism. As an example of this sort of limitation of senses, if someone who is hearing impaired were to go to the ballet, for example, that person, based on their sensory perceptions, focused mainly around sight, would be able to determine much of the full reality of the performance, including the presence of rhythm. But due to the limitations of the data gathered by their senses, they would not create a picture or model that would include the music as the underlying cause for the rhythmic motions of the dancers. Hence, our deaf person's understanding and thus description of the ballet will be incomplete. While their description will be true for them and their belief in it will be justified, it will not encompass the full nature of the performance. We will return to this example shortly. Out of these positions will grow something known as positivism. While this philosophical framework goes beyond just looking at issues in science and how it knows things, we will constrain our discussion to just those sorts of things. For the positivists, whose work in scientific inquiry is best expressed in the writings of Ernst Mach at the University of Vienna, the only thing a scientist has is the observable data. Anything beyond that is mere speculation and thus cannot be said to exist. Mach is famous for his opposition on these grounds to the atomic theory of matter. He claimed that all one knows about is the data from things such as chemical reactions and the various laws relating the variables of a gas in a container. He said that while one might be able to explain this data by positing things like atoms, that doesn't mean they actually exist, as a realist would claim. For Mach, the description of matter that relied on discrete entities was no more valid than one that was based in a framework where there was no void and all things were continuous in nature. To return to our person at the ballet, he may see that all the dancers are moving rhythmically by seeing the synchronization of their motions. This is an observable fact. Anything beyond this, says the positivist, is mere speculation, and thus there is no basis to suggest that it accurately describes the reality of the situation. They would point out that since our person couldn't hear the music, they might propose any number of explanations for the cause of the synchronization, such as visual cues from the conductor in the orchestra pit or periodic vibrations in the floor of the stage. While such descriptions of the system might be consistent with the sense data, one can't say anything about their truth. As such, Ernst and his fellow positivists would say that either the additional description is unfounded and should be ignored, the view of those who held a strong positivist position, or that the additional descriptive elements can be thought of as merely as something to aid in making prediction about a system's behavior. In the case of the ballet, our attendee will have constructed a possibly useful but factually inaccurate picture of the full experience because he cannot access all of it. In terms of our previous episode in the Bohr-Einstein debates, the unheard music would constitute a local hidden variable of which he is unaware. For the record, while Mach spent most of his life arguing against the existence of atoms, it was Einstein's paper on Brownian motion published in 1905 that finally convinced him to relent. The paper worked out a mathematical explanation of the motion of small particles suspended in a fluid. This mathematical description assumed that there were smaller, unseen particles jostling the larger particles around. The mathematics were able to describe the statistical nature of the motion very accurately, something a continuous model of matter was completely unable to do. As I mentioned in earlier episodes on Pauli and Heisenberg's, Mach's positivist views would have a profound effect on the philosophical position and interpretation of quantum mechanics. For the European physicists of North and Central Europe, physics was about more than just calculating and predicting the behavior of physical systems. It was a metaphysical endeavor that tried to explain the nature of reality. While the semi-classical model of Bohr and Sommerfeld initially attempted to describe the motion of electrons around the nucleus in terms of orbits in analogy to planets moving through space around the sun, something embraced by de Broglie, Einstein, and Schrödinger, Pauli and Heisenberg realized that one couldn't actually observe these orbits. Working from the positivist position that the only thing one could believe were the observable quantities, Heisenberg, after a series of letters with Pauli, discarded them entirely and focused on building matrices of transition probabilities, something that could be directly determined from the spectral lines of an element. It was this embracing of Mach's dictum to focus on observable quantities and observable quantities only that would eventually lead to the Copenhagen interpretation. As we have seen, this view of quantum theory is an explicit rejection of the realist picture that there is an objective reality independent of the observer. In the Copenhagen interpretation, It is the means of observation a researcher chooses that determines the kind of data the observer will collect. If the researcher sets up an experiment that looks for wave properties associated with a quantum mechanical object, the researcher will collect data that supports that picture. If, on the other hand, she seeks to collect data that would find a particle nature for that system, she will gather that. In this way, the observer determines the outcome of the observation. For the positivist, since the observational data is all one can be sure of, this is all one can say about the reality. In addition to this, because of the probabilistic nature of the state of the given system, the Copenhagen interpretation also says that the act of making an observation of a system with more than one outcome state causes the superposition of those states to collapse. In other words, the observer collapses the superposition of states and thus, in a sense, participates in the outcome of the experiment. Thus, the realist assertion that reality is independent of the observer is fundamentally undermined by the interpretation. In this, I think one can see why someone deeply committed to a realist philosophical position, someone like Einstein, would have serious reservations with what Bohr, Born, and Heisenberg proposed. However, as I discussed in the last episode, it's become pretty clear that Einstein's proposal of local hidden variables to rescue the realist position has been pretty well disproved, at least until some enterprising theorist finds a loophole in the Delft experiment that might, under some set of really exotic conditions, allow for a possibility of that being the case. Much more likely at this point is if one wishes to work to save the realist view, one will have to use one of the other interpretive frameworks that we've mentioned, such as pilot wave theory, the transactional interpretation of the wave function, or the many worlds hypothesis. In our next episode, we'll take a look at some of the more modern work in this area of philosophy by discussing the positions of local positivism as well as modern instrumentalism, philosophical arguments that hold sways in the minds of many today. As I close, I would like to thank Dr. Evan Butts, my colleague in philosophy, for his input on this episode. His comments on the rough draft improved it substantially, helping to clarify some of the points related to phenomenalism and representationalism. However, it should be said that any remaining errors in what has been presented here are entirely my responsibility. So, with any luck, we'll gather back here at the local coffee house in about a week, as the Dutch mariners of old used to do, and we'll continue to consider further the implications of what we've seen on our voyages to uncharted waters. If you know of any other adventurers who might enjoy our tales of nature's hidden secrets, feel free to invite them to join us around the table. Until then, full sails on your journey.